Hello there. It's another time for our lesson in science. We are looking at the topic activity series today. Now, the objective of this lesson is to help you to define activity series. You should be able to arrange metals and non-metals in the order of their reactivity. And you should be able to describe the actions of metals on water, mineral acids, and displacement reactions of metals. Now, we're going to look at activity series. What is it? Now, activity series is one of the topics in chemistry that explains how metals and non-metals are arranged in the order of their reactivity. Not only that, it also helps to predict how metals will react with certain substances. You see, and that is why you see why it's important. It also helps to predict the actions of metals or certain metals when they react with other substances. So activity series is the arrangement of metals and non-metals in the order of their capability to react in a chemical reaction. Now, what we have here is the activity series of metals. Now, you can see that you have metals here arranged in a certain order from potassium to gold. We have potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, and gold. Now, you may be wondering what hydrogen is doing there, because hydrogen is a non-metal. But the reason hydrogen is here is because hydrogen can be found on the periodic table in group 1. So it's among the group 1 element, though it is a non-metal. Why? Because other group 1 elements have one electron in their outermost shell, and hydrogen also has one electron in its outermost shell. That is why it's grouped under metal, as you see in this table right here, though hydrogen is a non-metal. But also it behaves as a metal in reaction. It carries a positive charge. So that is why it is here. So now, from this reactivity series of metal, you can see that from potassium to lead, those metals above hydrogen are more reactive than hydrogen. And copper, mercury, silver, and gold, that is below hydrogen in this series, are less reactive than what? Than hydrogen. And they have been arranged in such a way that the most reactive metal, potassium, is at the top, and the least reactive metal, gold, is at the bottom. So as you go down from potassium to gold, there is a decrease in this chemical reactivity. Now, as we look at some of the examples and reactions of metals, you see why potassium is the most reactive and gold is the least reactive metal. Now, moving along, what you see here is the activity series of non-metals. Yes, there's also the arrangement of non-metals in the order of their reactivity. And as you can see in this series, we have fluorine, chlorine, oxygen, bromine, iodine, sulfur, and phosphorus. Now, the most reactive non-metal in this table is fluorine, and the least reactive is phosphorus. So as you can see, as you move from the top, from fluorine down to phosphorus, the non-metals become less reactive. They become less reactive, which affects the way they behave when they are reacting with other substances. So now let's take a look at how activity series work in the actions of metals on water. Now, as you can see here, you have reaction of metals with water. Metals above hydrogen in the activity series will displace or replace hydrogen from water. For example, sodium, potassium, sodium, and calcium, which are high above the reactivity series for metals, will replace hydrogen from cold water. These three, they are all above hydrogen in the activity series, and that is why they will replace hydrogen from cold water. While magnesium, iron, zinc, and aluminum, which are also above hydrogen, will also replace hydrogen from water. But now, because potassium, sodium, and calcium, they are way above, they are way high in the activity series, they are more reactive than magnesium, iron, zinc, and aluminum. So that is why they will replace hydrogen easily from cold water. You don't need to heat the water, you don't need to you don't need to heat the water before they react. They react pretty quickly because they are the most reactive metals. But magnesium, iron, zinc, and aluminum, they are moderately reactive, and that is why it will require steam for them to replace hydrogen. They will have to react with steam, not cold water, but with steam, in order to replace hydrogen. But by and large, all metals above hydrogen in the activity series will replace hydrogen from water. So as you can see in the diagram that we have here, you can see sodium in water, potassium, magnesium, lead, iron, copper, aluminum. Now, sodium, potassium, magnesium, iron, aluminum, and lead, they will all replace hydrogen from water, albeit those that are high in the activity series would replace hydrogen from water pretty quickly than those which are below. But copper right here, that is below hydrogen, would not be able to replace hydrogen or displace hydrogen from water. Now moving along, we're going to look at the displacement reaction of metal. Now metals higher in the activity series can displace any metal below it from a solution of its salt. For example, you can see in the diagram that we have here that zinc is more reactive than copper. So zinc as a metal will displace copper from its salt, which is copper sulfate. So zinc reacting with copper sulfate, zinc which is silvery white, and copper sulfate, which is blue, will form zinc sulfate. So you can see from the diagram that we have here that zinc has replaced copper from its salt. So what we have is zinc sulfate, which is colorless, and copper, which is red brown. And if you try to displace zinc with copper, there will be no reaction. Why? Because zinc is above copper in the activity series. Now moving along, let's look at one more example. Action of metals on dilute mineral acids. Metals above hydrogen will replace hydrogen from acids easily. For example, we have zinc, which is a metal reacting with tetraoxosulfate 6 acid, that's H2SO4, will displace the hydrogen, while the zinc, a zinc salt will be formed and hydrogen gas will be given off. So you have metal reacting with acid to give metal salt plus hydrogen gas. Now another example we have is magnesium reacting with hydrochloric acid and aluminum reacting with hydrochloric acid. Now if you notice the result of the reaction, we have the metal salts, magnesium chloride and aluminum chloride, which have displaced hydrogen from hydrochloric acid to liberate hydrogen gas. So this is a typical example because magnesium, hydrogen and zinc are above hydrogen in the activity series. So you see now why the knowledge of activity series is very, very important. It can help you predict the action or the reaction and product of any reaction that involves metals and non-metals, especially when reacting with certain substances. So that brings us to the end of our lesson for today. Now let's look at the summary. Activity series is the arrangement of metals and non-metals in the order of their capability to react in a chemical reaction. In the activity series of metals, potassium is the most reactive while gold is the least reactive. In the activity series of non-metals, the least reactive is carbon while the most reactive is fluorine. Activity series can be seen in chemical reactions involving metals such as actions of metals in water, displacement reaction of metals, and action of metals on dilute mineral acid. We've come to the end of our lesson. Now I want to pause this video. I want to go through the assessment and see how much of the lesson you have understood. Till I see you again next time.